Okay, we are going to be going over log inequalities, which are fun for everyone. We all love log inequalities, right? Right? Yeah, we love these. Okay, so as inequalities go, we have our number line, right? But what we put on this number line is different, and it's weird. So we're going to figure this out right now. Our first step is the domain. And what that essentially means is we cannot go below a certain number. I'm going to put a sad face here because we know bad. But there's some number that we cannot go below. Because if we do, then that would mean that we're logging negative numbers. Right? And we can't do that. Or we're logging 0, and we also can't do that. Okay? So the way we get that is in this format, you just look at this one. Because think about it, when you combine these using properties of logs, you get something that looks like this. X squared plus 3x minus 5 over 7x plus 16. Now, if this down here turns out to be negative, or it turns out to be 0, then everything is wrong, because you can't log negative numbers, and dividing by 0 isn't a possibility. So this is our kind of floor. Lowest spot. So we solve for this to get our floor. So what x value here, what x value does this equal? So that's what we're going to do right now. So 7, we set this equal to 0, equals 0, and then we solve. It's just like a quadratic, where you just set it equal to 0 and solve for it. 7x. So we have x equals negative 16 over 7. So that is our floor. Negative 16 over 7. We cannot, any numbers that are below negative 16 over 7, we cannot, they just don't exist. Just completely ignore them, pretend that they never came about, right? Now I'm going to turn this into a mixed number just so that we can better compare it with other numbers, because 16 over 7, let's say I have a negative 3. It's kind of hard to compare. So I'm going to turn this into a mixed fraction. So it's actually 2 and 2/7 negative. Make sense? So this is our floor. We cannot go below this. And again, to get our floor, just in this format right here, get the one that's being divided by, the denominator. Get this right here. I set it equal to 0, solve for it. That's our floor. So now that we're on the floor, we have to get everything else. And now there's two different quadratics we have to solve for this. We have to solve this, and we have to solve this. Maybe wondering, like, okay, those are kind of the same. Or like, why both? It's just confusing, right? But imagine it as you're solving these independently, and then you're solving them combined. Because you can't log a negative or 0. Can't log a negative or 0. And if you combine these together, it makes you a different expression. And you also can't log a negative or 0 in that expression. Okay? So we're going to solve everything, each part. So part 1, part 2, and then we combine them here to make part 3. Okay, I don't know how much I cut off of this, because I did something completely wrong, but that's alright. So we're going to take this here, and we're going to solve for the things we're going to put on our number line. So in this case, you could just take this out. Don't worry about the log, just take this out. So x squared, because think about it. If any of the solutions inside of here are negative or equal to 0, then that means that the entire log is wrong. So we don't even have to worry about it. So x squared plus 3x minus 5. Set this equal to 0. And then, okay, let's factor this. We can't factor this. So what do? We plug it into the quadratic equation. So we say x is equal to negative b, which is 3, negative 3 plus minus square root of b squared, 9, plus minus, not plus minus, minus 4, then a, which is 1, c, which is negative 5, over 2a, 2. Let's make this happen. So, negative 4 times negative 5, negative 20, 9 minus 20, hello? Okay, let's combine this. So, we have, let's just put this in parentheses here. We have 4 times negative 5, and that's equal to negative 20. So, 9 minus negative 20 turns into a plus 29. So we have negative 3 plus minus 29 over 2. Great, right? That's awesome. We love that. That's not negative. We can use that. So there are two realities. One where this is negative, and one where this is positive. So this is where you get your handy dandy calculator out. Sorry, I had to find the link again. So we get our calculator and then we calculate. So negative 3 minus, let's see, negative 3 minus the square root of 29 over, I'm gonna put parentheses on this because I don't want any order of operation issues. That's not what I wanted. That's also not what I wanted. Okay, just bear with me for a second. Insert. There we go. Negative 3 minus square root of 29 divided by 2 gives us this number, which is below our floor. So we do not care about it. We're going to ignore it and pretend that doesn't exist. So we're going to put it in the sad box. Sad. We don't like him. Lock him up. Right. But we are now going to, I don't know why this minus is here. We're now going to try this solution. So we have, I'm actually going to go up and just edit this. I cannot. Okay. We have negative 3 plus second square root of 29. Not what I pressed. Thank you. And then divided by 2. Gives us a number, which is above our floor, which is negative. So 1.1925. So we have 1.1925. And that's great. We love that. Awesome. Right? Sad box, because it's negative and it's below our floor. If it was a negative number and it wasn't below the floor, it'd be fine. But this one's it was below the floor because it's negative 4. But this one, we like this one. This is good because it's above our floor. It's this number right here. So, you may think we're done, but we're not. I'm just going to erase all this down here because now we need to move on to step 3. And step 3 is solving the combined expression. So we need to solve this right here. So let's set this greater than 0 because that's what it is. That's what we do for the combined expression. And then we say, okay, this is log of 10. And for log expressions, the way I like to explain it is log b x equal to e. Actually, no, I'm not going to put e. I'm going to put c. So when you read a log expression, the way you should understand it is b to the so b here to the power of c is equal to x. So when you're reading a log, it says b to the power of what is equal to x. So b to the power of something is equal to this number. And the solution to that conundrum we got there is c. So if we were to turn this into an exponential, we get b to the power of something, that something is c, is equal to x. Right? You can imagine like the x just like jumping on top of this guy and then displacing him. Right? And then just getting rid of him, and then he has to run back to b. So that's how you convert. That's how I like to think about converting. So we're going to do the same thing here. And now, in this situation, when you convert, you are going to keep the x's on the same side. Do not move them. Keep them on the same side of the inequality. It is much easier that way. It will get you the right answer. If you're going to ask why, like what's the mathematical reason that's necessary, beats me, I have no idea. So 10 to the power of what is equal to this? 10 to the power of 0. Right? Which is also just 1, because anything to the power of 0 is 1. So I'm just going to erase these. So now what do? Multiply 7x plus 16 on both sides. I'm sure you guys know how to do that. I'm sure you understand how that works. This is not Algebra 1. If you don't understand that, I can't help you. I'm sorry. I'm sorry. I can't. So there we go. That's our expression. And all we do now is just combine them. So subtract 7x, subtract 16. We get x squared minus 4x plus 11. That should be right. No, because I'm subtracting. Minus minus, that's minus 21. Yes. Okay, that should be right. So now I solve for this. This is greater than 0. This, I believe we can factor. So 21 is comprised of -7 and 3. And then it doesn't really matter the order here. X minus 7, x plus 3, greater than 0. So let's solve for each of these. So x plus 3 would equal x equals -3, and x minus 7 is equal x equals 7. X equals -3. We don't like that. That's bad. So they get imprisoned in the sad box. How about x equals 7? Yeah, that's fine. We like that. So they're good. And keep in mind, even though it has been only one thing being right in this example, they could both be right, they could both be wrong. It depends. So x equals 7. Doink. So now, let's double check that we did everything. We did step 1, that's our floor. We did step 2, just this. Why did I put, oh yeah, that's step 2. So, I'm going to erase this for clarity's sake, because it confused me for a second. This is step 2. We did that. We got this, and we got -4 point something, which is gone. We don't care about it, it's in the sad box. And then we combined the two using properties of logs, and we got this, which is step 3. And then we solved for it, and we got two things. One was in the sad box because it's below our floor, and then one was above our floor, so it's a 7, so we're good. Now, what we have to do is put in test values. My favorite test value is 0, just because it's easy. So this is a negative number and a positive number. Between the two, we can just put slap 0. And we are going, keep in mind, the place you substitute values in is this factored expression right here. So don't forget that it's this right here that you have to substitute values into. Not this, the combined expression. Alright? Because inevitably, that's what the final function is going to look like. So we have, let's substitute 0. So 0 minus 7, negative. 0 plus 3, positive. We get a negative sign right here. I'm going to make this red. Negative. How about we substitute in a number between these two? I'm going to put 2. 2 minus 7, negative. Should be negative. 2 plus 3, positive. So this is negative. And then finally we have 10. Our final test value, 10. I just said it, whatever. 10 minus 7, positive. 10 plus 3, positive. So out here we have a positive sign. So, what is our answer? Well, the problem is asking for what is greater than 0. So, the only thing that's positive here, and we don't like this zone. We don't like them. That's like the abyss. We don't go down there. This is the only thing that's above 0 because it's positive. And always remember that it cannot be 0. So our final answer is 7, comma, infinity, x equals. Ta-da! There we go. These are, they have a lot of real weird rules, but if you practice, you'll get used to them. One thing you need to remember is that if you cannot factor it, you have to use the quadratic equation. Quadratic equation, if you don't have it memorized already, I highly suggest you memorize it. Negative b plus minus square root of b squared minus 4ac. Every time I write this out, I feel like a genius, even though it's like normal. This is quadratic formula. So if you don't have it memorized, you need it, because if there's any irregular things that don't want to get factored, then you're screwed. That's all there is to it. You're kind of cooked. But if you use this, then you can factor anything you want. And that is going to be all. That's going to be our example. I hope this helped. And if you have any follow-up questions, I'm going to be available. It's Sunday, test is tomorrow, so if you have like a question and it's before a reasonable hour, like, I don't know, if you ask a question at like 9, I'll be able to, I'll make a video answering it if you want, or I'll comment. But I'm here if you need anything. But I hope this helps. Later, man.